The binding energy, the strong nuclear force in the gluon field is so powerful that it contributes 99% of the mass to each proton and neutron in the universe. This force is like the most powerful rubber band imaginable, holding the three quarks together within each proton or neutron. It is so powerful that protons almost never break apart or decay. What this means is that your mass, your weight on planet Earth, along with the mass of everything you can see, everything, is 1% elementary particles, mostly quarks and a tiny bit electrons, and fully 99% binding energy. When I learned that fact, it blew my mind. I have pondered on it many times over the years. It still amazes me. We are 99% binding energy. Let that sink in. We're 99% binding energy. Who knew that Yoda had it right? We are all bound together by a field of energy, the gluon field, or the strong nuclear force. Welcome to Being Humans. We're better together. I'm Ian Christopher Wendt. In this third series of episodes, we're going to delve into physics to demonstrate that the architecture of the visible universe and all life is based on bonds and binding energy. This reality can help us recognize that our bodies, brains, and minds are characterized not by separate bits, but by bonds. From elemental particles to fundamental forces and fields, to chemical bonds and organic compounds, to cells and organisms, to complex biological creatures in living ecological webs, to intelligent, conscious humans in networks of relations, communities, and social fabric. We are bound together in ever more complex structures and networks, from our fundamental physical core up to our most elegant philosophical constructions. The universe itself demonstrates that life is not about bits, it's about bonds. We are not isolated and alone. We are bound together in meaningful communion. If we live that way, we will find ourselves in greater harmony with the structure of the visible universe and greater harmony with one another. Next, we'll try to demonstrate to you that life is rare, beautiful, and precious, and conscious life is more rare, beautiful, and precious. And we should live to preserve and expand that life. Too many people in this misanthropic era look around at other human beings and see only parasites, overpopulation, and meaningless lives. This is self-destruction. I hope to share a different perspective and paradigm with you. Finally, modern physics reveals a significantly mysterious, unknown universe. Physics as a discipline made great advances during the 20th century, but I think it's fair to say that 21st century physics is in a speculative and philosophical malaise. I'm not expert enough to help solve any of their challenges, but I can recognize that physicists continue to speculate and promise the theory of everything, even as they admit they can only imperfectly glimpse the functioning of a small corner of 5% of the universe. Don't get me wrong, what they do is amazing, but we all need to cultivate and practice humility in the face of the unknown. We ought to recognize that there is ample space in the known universe for many of the things that reductionists and atheists will tell you do not exist. And being humble and open-minded is a better, more effective way to live than to needlessly adopt anti-human, misanthropic, nihilistic ideas. So that's our introduction to the paradigm shifts we'd like to develop during this series on binding energy and the preciousness of life. If you've been following our earlier episodes, you'll remember that I voiced a bit of criticism of the reductionism of physicists. Let me say that my criticism comes from a place of friendship and respect. I enjoy physics very much, or at least the kinds of physics that historians can understand. I'm no physicist. I don't claim to have the variety of intelligence and expertise they have. But during my earlier life as an academic at universities and colleges, I really enjoyed my friendships and discussions with physicists. And I've read numerous physics books and articles written for general audiences. Everything from history of science and the scientific revolution, which was centered on physics and astronomy, to biographies of great physicists like Albert Einstein, to explanations of the transition from Newtonian physics to Einstein's general relativity, to the development of quantum mechanics. I've followed modern physicists down their fascinating wormholes, where they speculate about black holes, string theory, extra dimensions, multiverses, dark matter, and dark energy. These speculative realms, many of which have no connection to testable physical science, constitute philosophy, or dare I say religion, for physicists. And I enjoy them a great deal, the same way I enjoy most philosophy and religion. From this place of earnest respect and interest, I'm going to attempt to describe some of the modern history of physics and how applying the knowledge of contemporary physics can directly contribute to having a more connected, meaningful perspective on your life and humanity generally. As a layman, I will inevitably misstate some physics principles, for which I apologize. I will also criticize some of the physicists' philosophy and speculation. If I have the great good fortune of attracting learned physicists into discussion with me on these topics to improve and develop our conversation going forward, I would be very glad to expand these discussions in the future. During the scientific revolution from roughly 1540 to 1700, astronomers and physicists laid the foundation of modern science and the technological advances that shape and characterize the modern world. Copernicus decentered the Earth and described the structure of the solar system. Galileo used telescopes to strengthen the model of the solar system and to show that the objects in space were made of physical, imperfect planets, moons, and stars rather than perfect heavenly lights. Eventually, Isaac Newton used math, calculus, which he invented, to demonstrate that the motion of the objects in space and on Earth followed laws of motion that could be captured in mathematical equations. From these foundations, eventually developed chemistry and then biology. Then came political economy, from which the less exalted modern social sciences grew. Physicists use math to describe the movement and function of elemental particles and fundamental forces. For this reason, they consider themselves to be the elite of science. During the 20th century, Albert Einstein showed that the fabric of the universe was four-dimensional space-time, and that the motion of all of the objects in the universe was governed by a modified concept of gravity and by relativity. Of course, science was not just performed by four men. Science has long been practiced by many scientific minds using mathematics, theory, and experimentation to develop an ever-expanding and deepening understanding of the physical properties of our world and our universe. 2 generations of physicists worked with Einstein to develop modern cosmology, including a vast universe composed of innumerable galaxies. Niels Bohr, Oppenheimer, and many others cracked the atom, developed nuclear technology and power, and quantum mechanics, which describes the counterintuitive rules that govern the function of subatomic forces and particles. Throughout the 20th century up to the present, the great goal of physicists is discovering the theory of everything. The theory that could combine the cosmic scale of gravity and relativity with the subatomic scale of protons, electrons, electromagnetism, and nuclear forces. As physicists have delved further into the cosmic scales of galaxies and the quantum scales of particles, they have come across numerous discoveries and surprises. They've developed the Standard Model, which characterizes all of the known elementary particles and the 3 forces that act on them: electromagnetism, the strong and the weak nuclear forces. They also came across the boundary of our ability to observe tiny objects, scales, and forces, beyond which there is always uncertainty. In cosmology, Hubble and others demonstrated that the universe is expanding, And recently they found that the expansion is accelerating. They also saw that galaxies spin much faster than the gravity of visible matter alone would dictate. From these mysteries, they have theorized the existence of dark matter and dark energy. These are as yet undetectable, unmeasurable particles and forces. In the face of these surprising mysteries, physicists have delved into increasingly complex and, dare I say, mystical forms of mathematics and speculation. After 50 years, string theory with its 9 dimensions and vibrating rubber band reality seems to have turned out to be a mathematical and theoretical dead end. Its theorists hoped it was the grand unifying theory of everything, but its predictions cannot be tested, and its constituent strings and loops cannot be observed. Other physicists have embraced the multiverse, wherein universes like ours are layered and stacked as brains across incomprehensible dimensions. Through it all, we remain unable to use math and physics to connect gravity with electromagnetism and the nuclear forces, and we have no idea what dark matter or dark energy are. Personally, I find every part of this scientific story fascinating. I'm amazed at the ingenuity of physicists and astronomers. Over the last 125 years, physicists have expanded our vision of the universe from our solar system within a single galaxy, the Milky Way, to an incalculable immensity of galaxies moving through the universe. They've revealed so much of what can be seen. They've identified the vast limits of dark matter and dark energy that cannot be seen. Scientists and engineers have cracked the genome, taken us to other planets, built computers, and have placed all human knowledge in the palm of your hand. And we use that technology to anonymously yell at each other and watch cat videos. With that brief introduction to the history of modern physics, permit me to lay out the key components of the universe. According to contemporary physics theory, the universe is composed of 5% visible matter: stars, planets, protons, and all living things. 5%. 27% of the mass of the universe is dark matter. We don't know what it is, but there are a variety of evidence that lead physicists to conclude that it exists, that it makes significant contributions to the shape of galaxies, their movement, and to the massive structures of the cosmos. Physicists believe that dark matter only interacts gravitationally with visible matter, that it does not interact with electromagnetism or the strong or weak nuclear forces. Physicists theorize that dark matter particles move very rapidly through the cosmos in clouds around galaxies and in streams between clusters of galaxies. They have found no evidence that dark matter binds together to form complex structures. Finally, the remaining 68% of the mass of the universe seems to be composed of dark energy, a force or pressure in space that seems to cause the universe to expand. We know almost nothing about it. Because dark energy is such a complete mystery, we'll set it aside as we continue. Today, I want to focus on the main constituents of matter. In high school physics, you learned about protons, neutrons, and electrons. 60 years ago, physicists discovered that protons and neutrons were not fundamental particles, but that they were each composed of 3 smaller quarks. The current standard model of particle physics describes 6 quarks and 6 leptons, along with 5 bosons that mediate forces and give particles mass. There are also antiparticles for each of the quarks and leptons, but don't despair. The vast majority of the visible matter in the universe is composed of just 2 particles, up quarks and down quarks. To this we can add electrons and neutrinos. Moving forward, I will primarily refer to quarks, meaning up quarks and down quarks, and electrons. Learning about quarks changed my view of everything in the universe, including human beings. You probably know that a proton and an electron have opposite and equal charges. The proton is positive and the electron is negative. Protons and electrons usually bind in pairs, through electromagnetism to make the charge of most atoms neutral. For example, hydrogen has 1 proton and 1 electron. Carbon has 4 protons and 4 electrons, and so forth. But protons and electrons are not even close to the same size or mass. The atomic mass of a proton or neutron is very close to 1.0 AMU, atomic mass units. By contrast, the atomic mass of an electron is 0.00055 AMU, or atomic mass units. In other words, the proton's or the neutron's mass is almost 2,000 times greater than the electron's mass. This means that the mass of visible matter is almost entirely derived from protons, 90%, and neutrons, 10%. Electrons make up a tiny percentage of mass. Neutrinos are so much smaller that they make up a minuscule percentage of all visible matter in the universe. And we can discount the other elementary particles in this exercise because they are so much less common building blocks for visible matter. So, the mass of the sun, other stars, planets, moons, asteroids, nebulas, the Earth, plants, animals, and people consist of more than 99.99% protons and neutrons. But a proton is composed of 2 up quarks and 1 down quark. A neutron is 2 down quarks and 1 up quark. Let's focus on the proton. The mass of the up quark is approximately 0.002 AMU. The mass of the down quark is approximately 0.005 AMU. The total mass of the 3 quarks in a proton is approximately 0.01 AMU. Wait, but wasn't the mass of a proton 1.0 AMU? So the mass of the 3 quarks that constitute the proton is 1/100th of the total mass. Just 1%. Yes, that's right. So that must mean that there are other pieces, right? Nope. Just the 3 quarks. So what constitutes the other 99% of the mass of a proton or neutron? The answer is binding energy. Gluons, or the gluon field, binds the 3 quarks together within each proton and neutron. This is the strong nuclear force. This force is so powerful that it absolutely dwarfs the strength of all other fundamental forces. The strong nuclear force is about 100 times stronger than electromagnetism. The strong nuclear force is 1,000,000 times stronger than the weak nuclear force. The strong nuclear force is 100 trillion times stronger than gravity. I can't really comprehend that either. Remember Einstein's famous equation, E equals mc squared. The binding energy, the strong nuclear force in the gluon field is so powerful that it contributes 99% of the mass to each proton and neutron in the universe. This force is like the most powerful rubber band imaginable, holding the 3 quarks together within each proton or neutron. It is so powerful that protons almost never break apart or decay. What this means is that your mass, your weight on planet Earth, along with the mass of everything you can see, everything, is 1% elementary particles, mostly quarks and a tiny bit electrons, and fully 99% binding energy. When I learned that fact, it blew my mind. I have pondered on it many times over the years. It still amazes me. We are 99% binding energy. Let that sink in. We're 99% binding energy. Who knew that Yoda had it right? We are all bound together by a field of energy, the gluon field, or the strong nuclear force. Let's continue. We already noted that the matter in the universe is visible matter and dark matter. Remember, physicists tell us that 5% of the mass of the universe is visible matter and 27% is dark matter. So dark matter is roughly 5.5 times more prevalent by mass than visible matter. We'll set dark energy aside because no one really knows what it is or what it does. We're just talking about matter in the universe. The visible matter is made of quarks and electrons that bind together and interact with the strong nuclear force, electromagnetism, the weak nuclear force, and gravity to produce all kinds of atoms, from hydrogen to carbon to oxygen to plutonium. Those atoms combine in complex structures to form stars, planets, moons, comets, cows, babies, and everything we can see or touch or measure. The dark matter does not clump together, bind, or combine. Dark matter does not seem to interact with the strong, weak, or electromagnetic forces, and it doesn't seem to clump together to form structures that we can find or measure. There's no evidence of dark matter stars or planets, or even atoms or molecules. It seems to only interact gravitationally in great clouds of particles moving rapidly around galaxies and galactic clusters. So what happens if we try to compare the mass and number of visible matter particles with the possible mass and number of dark matter particles in the universe? This is speculative, but it opens an interesting point about how special the properties of visible matter are, and therefore the building blocks of the visible universe. If the scale or mass of visible matter particles, of which up quarks, down quarks, and electrons make up almost all of the mass, are roughly similar to the scale or mass of dark matter particles, then there are about 5.5 times as many dark matter particles as there are visible matter particles. We don't know. Dark matter particles could be much smaller, in which case there would be many more of them. They could be bigger. For the sake of a simple comparison, let's guess that they're similar in scale. If so, there must be about 5.5 times as many dark matter particles as there is light matter particles, right? But the mass of visible matter is 99% binding energy. Since dark matter particles don't bind or clump together or react to forces like the strong nuclear force, then dark matter particles do not have a 100 times mass multiplying force like the strong nuclear force. Thus, it stands to reason that the number of dark matter particles would need to be 100 times greater to make an equivalent mass. If that's even approximately correct, then there would be about 500 dark matter particles for each quark or electron. 500 dark matter particles for each quark or electron. If we take into account the mass multiplication that occurs in visible matter because of binding energy, the strong nuclear force, and dark matter lacks that property, then visible matter particles would constitute much less than 1% of the matter particles in the universe. If this is even remotely accurate, then you begin to see how important the binding, combining, reactive nature of quarks and electrons are. Because quarks and electrons bind, combine, connect, and interact with each other, because they respond to the strong and weak nuclear forces, electromagnetism, and gravity, these rare little particles became the building blocks for the entire universe, the entire visible universe. Physicists tell us that the universe is composed of much, much more stuff, dark matter, etc. Based on our speculation, quarks and electrons are probably less than 1% of all matter particles in the universe. But they bind together, and they make everything we see, touch, and connect with. They make us. We are 99% binding energy. 99% of our mass comes from the strong nuclear force. The strong force binds the protons and neutrons in every one of our heavier atoms together in their atomic nuclei. Electromagnetism binds the protons and electrons in everything together. We see electromagnetic waves. When we touch something and push against it, we feel a solid surface because the electrons in our skin push against and repel the electrons in the object we are touching. The complex organic molecules that form every structure in our bodies are formed by sharing or exchanging electrons between atoms in complex structures like sugars, proteins, nucleotides, etc. The nucleus and organelles of all living cells are made of even more complex structures of molecules connected and bound together. Our cells combine into tissues of many kinds, each defined by the DNA and proteins they manifest, binding, connecting, building complex structures, making life. Binding energy makes mass. Binding and connectivity makes structure, from stars to planets. Binding makes life, organic compounds, cell structures, living organisms, all of the way to humans. And it all starts with 3 magnificent little quarks bound together in a proton. Did you know that quarks very rarely occur alone in the universe? Here on Earth, you need to blast a proton with a huge amount of energy in a particle accelerator to separate quarks. They are almost always bound together in 3s. Dark matter is all around us, throughout the universe. Our speculations may be inaccurate. Yet, if physicists can speculate about multiverses, string theory, and 9 dimensions, then we can make a basic guess about the scale of dark matter particles. We don't even really know what dark matter is, but we know that something like it shapes our galaxies and cosmic structures. So quarks may be 1 in 500 matter particles in the universe. They may be only 1 in 5, but they bind together. They make our mass. I like to think that they're 1 in 500. I think they're rare and beautiful. Along with electrons, they are the building blocks of all of our structure. Strangely, physicists do not commonly emphasize the importance of how the peculiar binding properties of visible matter particles likely give them a significantly greater influence on the universe in comparison to the far more numerous and massive dark matter particles. I don't know why. To me, it is by far the most interesting and significant aspect of these fundamental particles. I don't know why everyone doesn't love quarks. They're one of the coolest little principles I've ever learned. You are 99% binding energy. Quarks combine to make the entire visible universe. I don't think these principles are just an analogy for life or human consciousness. I think these principles are the foundation of life and consciousness. You are not alone. You are not isolated. You are not meaningless. You are a profoundly complex, interconnected living being with intelligence and consciousness, capable of seeing and understanding and experiencing the incredible beauty of the universe. I do not know why I'm alive. I don't know why you are alive. I have beliefs, but I know that it is amazing to be alive. It's amazing to see the universe and all of the incredible things that exist on this planet. Oceans, mountains, beaches, clouds, lakes, streams, plants, fish, sharks, octopuses, trees, flowers, so many kinds of bugs, horses, lions, birds. I love birds and people. So many kinds of people, so many ways of being a person. I try to be a philanthropist. I love humans. If this has opened your mind to a new view of the universe and your place in it, please share it with someone you know and care about. Celebrate being alive and being human today with someone who means a lot to you. And please join us. Like, subscribe, share, comment, support. Amen, amen. This is the way of being humans together.